In the previous example, we have used that 150 psi as the cracking pressure. However, it says this is it operates at 150 psi. Now, if you don't want the water heater to go over 150, then you cannot solve the way we have solved the problem in the previous example. I just showed you how to calculate the cracking pressure in the previous example. If you don't want this water heater to go over 150, then it should be a little bit different calculation. So let me show you that. So think about the same kind of like a ball spring. This is the free spring length, and then you use this spring to design a pressure relief valve, and then you compress this ball against some kind of seat like this. So um, and the flow is coming this way. That's 150 psi. So that is the initial compression of the spring. So that will exert some force downwards to balance this pressure coming upwards. Now, to make full flow, if you just balance the force by 150 psi, it's not going to make full flow. So to make full flow, you have to leave this ball, let's say 0.1 inch lifted. The spring will be even more compressed now. So the total force applied by the spring now would be K times the spring constant plus that full flow movement. K is the spring constant, sorry. And then S is the initial compression. So this is the total compression and the full flow, whatever that amount to be lifted to make the full flow. Now, the force we can calculate using the same thing we did before. So this psi times the area of this pipe, which was calculated as 0.196 inches square. So that was 29.4 inches square, pound. Now we can solve this thing for 29.4 pounds is equal to 100 is the spring constant, pound per inch. And then you got S plus 0.1. So if you solve for S plus 0.1, that will be 0.294 inches. Then the initial compression will be 0.194 inches. So that is the initial compression kind of changes. If you look at this 0.294, it's the same number we calculated before. Now, if we now kind of calculate the cracking pressure or cracking force, then the cracking force would be F equal to K times S, which is K is 100 times 0.194. So that's going to be 19.4 pounds. If you want to convert that to pressure, simply force is equal to F by area, 19.4 divided by area 0.196. So that's become about 99 psi. So what's going to happen is when the water heater reaches at 99 psi, then this valve will start to open. It will just balance at 99. It will not fully open. However, as the pressure increases, it will start to move up. And then if it goes over about 0.1 inches from the seat, it's going to make the full flow and reduce the pressure to 99. And then it will maintain 99 inside pressure. So